Hi, I'm Dave Baring, Technical Director here at TriStar, and welcome again to Tech Talk. Today, we're talking about surface finish. Plain bearing design, key factor in how well a plain bearing is going to function, especially a plastic plain bearing, is how well is that surface finish being monitored. It's absolutely critical, not only to frictional properties, but also to wear properties, that the surface finish fall within an optimized criteria. And for us, we like to see an 8 to 16, 8 to 12 would be for us an optimized surface. So we're going to talk a bit about how surface finish can affect wear. Certainly it's obvious that a rough surface is going to wear that plastic material out fairly quickly. But there are things that can be done to accommodate rougher surfaces. There are material selections that can be made with the understanding that as long as the other parameters like PV and temperatures, environment all come in within those material capabilities, then you can deviate a little bit from surface finish. Understanding though that when you do deviate, there's going to be some pretty severe ramifications in terms of wear. This chart that you're looking at right now is a good indication of one of our materials and how surface finish can affect long-term wear life. It's very obvious that from an 8 to a 32 finish, which doesn't seem like a lot, has dramatic impact on how well that material is going to wear. So when we talk to you about plain bearing design, as you've heard from other tech talks, there are very specific criteria that we design around to give you the best performance. Surface finish is just as important as PV and temperature and what kind of environment you're running in, because it ultimately has everything to do with wear and friction performance of that plastic bearing. Now, one of the other areas that is interesting is that the way that surface finish is prepared can also have an influence on how well that material is going to wear. Give you an example, we've done a number of tests on preparing a surface. It can all be a 16 RMS finish, for instance, but if that surface finish is prepared using a turning process, let's say, versus a ground and polished, or even versus a roller burnished surface, all the difference in the world on how well that same 16 RMS finish is going to function in terms of wear life. A lot of that has to do with how well that lubricating source, whether it be the PTFE in the material or graphite or moly or silicone, whatever the lubricating media is, how well is that material able to transfer into that surface finish. That really determines how well that material is going to hold up for the long haul. Our experience says that roller burnish surfaces, while it's a little more expensive and a little bit more cumbersome to do roller burnishing, it gives us the absolute best life in terms of wear and friction. It also generates a lot lower heat, and as you might remember from previous discussions, heat is a big factor in how quickly plastic plain bearings fail. So if you consider surface finish and really take heed as to the optimized conditions and how you get to those conditions, it will make a huge difference in how well that material holds up in your application. Now, just another note, this is something that sometimes gets missed in conversations, and that is that you can actually have too good of a surface finish. Plastic plain bearings, because of the technique or the process of transferring lubricant, they do need some microfinish in order for that transfer to take place. So it's important that we don't get too smooth. There have been very obvious cases where friction actually increases dramatically with the plastic material because the surface is too smooth. It's almost like putting two mirrors together. You can actually generate this vacuum effect of trying to move two very smooth surfaces together. It just doesn't work very well. So you can actually dramatically increase friction because the surface finish is too smooth. So when we're talking about 8 to 12, 8 to 16 RMS, it's not just a number we pulled out of the hat. It's a number that we have found to be most effective, as have everyone else in our industry. There are certain applications where polymers are utilized, for instance, in seals, like Teflon seals. There are some occasions where if the media, for instance, is a gas like oxygen or nitrogen, CO2, something like that, there are occasions where we'll design a surface finish or call out a surface finish in the 4 to 6 range because those environments require a very smooth surface to prevent too much passage of that gaseous media along that surface finish. So there are exceptions to the rule, but for most standard industrial designs, 8 to 16, that's the range you want to design in. That's the range that you're going to optimize performance. And if you need to understand more about that, we have wear data, some charts and things that we can share with you that show very, very clearly the difference between life at 32 RMS and life at 8 RMS. It's very, very eye-opening. So when you're designing plain bearings, surface finish, pay attention to it, and please give us a call if you have any questions on how to get to that surface finish. And then there's also discussions that have to come into play as well about treatments of those mating surfaces, and whether you use electroless nickel plate or chrome or PTFE hard coats, those all come into play and need to be part of the conversation as well. So feel free to contact us here at TriStar. We're more than happy to work with you on making that determination with you. It goes right along with the right material selection and really optimizing plastic plain bearings and seals to give you the best performance possible. Thanks for joining us again for another Tech Talk, and we look forward to seeing you soon. Bye now.